I'm Kenny Lee, and let's talk about average velocity or average speed. So we're going to use this equation right here. Velocity or speed is equal to displacement or distance over time. And this is the equation that we'll use to figure out the overall speed or velocity for whatever trip that we're taking. So let's take a look at some example problems. And we'll start off with something fairly easy. So let's start off with this one. We got a rabbit traveling 30 meters in 12 seconds. We want to know the rabbit's average velocity. But first, there's some things that I want to see, or most people want to see when you do a problem. We're going to use what's called the guess method of problem solving. The guess method stands for given, unknown, equation, substitute, and then solve. So this will give us a structure, because every question or every problem in physics is essentially a word problem. So we're going to start off with this as an example. So I'll start off looking at this. A rabbit travels 30 meters. Well, meters is a unit for distance, so we're going to figure out our givens first. So we're going to start off with distance is 30 meters in 12 seconds. So our time is 12 seconds. And we want to know the average velocity. So that's v. So there's my given and unknown. Now, sometimes that's not required for every single question, but if you're stuck, it's a good place to start off. So these are kind of optional for me, but maybe a good place for you to start, especially as the problems get more complicated. Unknown is our velocity. Equation. Now, I do want everybody to kind of start off here. This is a good place to start when you want to solve a problem. Start off with the equation. Velocity equals distance divided by time. You may want to solve it for whatever variable you're looking for. In this case, we're actually looking for v, so we're good. But that could be a little bit more algebra practice for you. And then we got the equation. Next thing we want to substitute in. So plug in these numbers where they go in the equation. So d is 30, t is 12. So now we just have to solve. So if I type this in, 30 divided by 12, we get 2.5. So it's 2.5. And our answer is not complete. We need another piece of information, the unit that it's in. Now this top was in meters and the bottom was in seconds, and we were dividing. So that's going to be our unit. Our unit is going to be meters per second. So this rabbit was going 2.5 meters for every second of travel. That's what the unit stands for. The units always give you that information. It's for every second that goes by, the rabbit's traveling 2.5 meters. So let's look at another one. So we've got a hiker is standing 400 meters in front of a cliff wall. The hiker yells, and here's the echo 2.5 seconds later. What's the speed of the sound? Well, in some cases, not only do we want to use the guess method, but sometimes it pays to draw a picture of the situation. So in this case, I want to draw a picture. It doesn't have to be a good picture. Mine never are. But it's just used to help me organize things. So our distance was 400 meters. And we had a time of 2.5 seconds. But here's the thing. It echoes. So that means the sound had to go out to the wall. Had to go out to the wall. That's 400 meters away. And then come back for him to hear it. So the sound traveled 400 meters to the wall and then 400 meters back. And so that really means the distance of travel is really 800 meters. Now, if you didn't read the equation or the problem, you may have left out that piece of information. So now that we got the given, we're looking for velocity again. So now we can set things up. Equation first, distance divided by time. We know the actual distance is 800 meters, and the time is 2.5 seconds. So we can bring that calculator back in. 800 meters divided by 2.5 gives me a speed of sound to be roughly 320. Again, top was in meters, bottom's in seconds. Meters per second. So that would be the velocity of sound in that situation. Well, we can solve for something else besides just velocity. We've got a couple other variables that we can use. So let's take a look at this one. We've got a toy going 0.8 meters per second, and we're asked for how far it will go in 12 seconds. So in this case, again, look at the units, it'll tell you where things go. 0.8 meters per second. So meters per second, that's a unit for velocity or speed. And again, we have a time of 12 seconds. And we're asked for how far. So in this case, we want distance. Again, start off with the equation. Then plug in your numbers. So we've got 0.8. Distance we don't know, but a time of 12 seconds. And so now we need to solve that. So now we're going to work on our algebra a little bit. So we need to get d by itself. So that means if 12 is divided by on this side, it'd be multiplied on the other. So we're going to multiply both sides by 12. Those cancel. And we're going to get 12.8 or times 0.8 equals d. Now you don't have to show all your steps, but you want to get enough idea that let your instructor know how you got your answers. So at least the equation substitute and solve. So now to solve it, we've got 0.8 times 12. So it traveled a distance of 9.6 meters. Now if you want to check that it's meters, the 0.8 was in meters per second, and then we multiplied by time. That's on top, so this cancels out that. It just leaves us with meters. So 9.6 meters is the distance that toy traveled. Let's try another. Solving for something different. In this one, we got a sprinter runs a 100-meter race at an average velocity of 15 meters per second. How long did it take the sprinter to finish the race? So in this case, we're looking for time because we got a distance of 100 meters. We have our velocity or speed of 15 meters per second, and we're looking for time. So again, start off with the equation. That's something you should show every single time. Then substitute in. V was 15. Distance is 100. And we're looking for t. Now, anytime you're solving for this denominator, you can always use the super secret math trick. And what the super secret math trick is, if you want to solve for a t, and it's kind of in this form, or, well, it could be anything in the denominator, you simply swap these out. So t would come out, and the 15 will take its place. And so 100 divided by 15 gives me a 6 with a 6 repeating, so 6.67 seconds. And again, if you're looking for the units, let's take a look at this. We've got distances meters, and it's being divided by meters per second. So that's on the bottom. It will flip up. Those cancel out and just gives us seconds. Now, you probably don't have to show your unit analysis over here, but you definitely need the unit for your answer. So this took that sprinter 6 2/3 seconds for him to complete the race. Here's one that's a little bit different. We've got a turtle traveling 3 meters in 10 seconds, stands still for 4 seconds, and then goes another 5 meters in 8 seconds. So he hits a burst of speed right there. We want to know the turtle's average speed. Well, you can always find average speed by taking the total distance divided by total time. We need to figure that out. So for distance, it traveled 3 meters plus an additional 5 meters. So it traveled a total of 8 meters. And for time, it went for 10 seconds, did another 4 seconds. Even though it was sitting still, time was still going by. And then another 8 seconds. Okay? So it traveled, or it took 22 seconds for it to do the entire trip. So we can do 8 meters, 22 seconds to get a total average speed of 0.36 meters per second. So the equivalent velocity of that turtle is, for every second, it traveled 0.36 meters. We've got a cyclist that's traveling 10 kilometers in 2 hours. We want the cyclist's speed, so we're looking for velocity or speed, but we want that in meters per second. You always want to make sure that your units match. If your velocity is in miles per hour and your time's in minutes, you want to change your minutes to hours to make sure that they match. In this case, we want to go from kilometers to meters and from hours to seconds. So again, we want the units to match what our answers should be in. So if we've got this one, we've got a distance of 10 kilometers, but we're going to change that to meters. So 10 kilometers, K means 1,000, so we got 10,000 meters is our distance. Time was 2 hours. But we need to change that to seconds. So 2 hours, we're going to change that to minutes, so multiply by seconds, or 60. And then to change that to seconds, we need to multiply by 60 again. 60 seconds in a minute, 60 minutes in an hour. And so we know, again, bring out the trusty calculator, that we got 7,200 seconds. Now, if you want to see this written out more formally, it looks like this. 2 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. Minutes cancel out minutes. Hours cancel out hours. Multiply by over across the top. Divide by the bottom, which is just 1. And we still get 7,200 seconds. So that's it written out more formally. But you don't have to necessarily show all that work. You have to see what your instructor wants. So let's take a look at solving this now. We've got velocity equals distance divided by time, or speed in this case. Distance is 10,000 meters. Time is 7,200 seconds. So 10,000 meters divided by 7,200 seconds. That means this cyclist is going 1.39 meters per second. And that's his average speed over the entire course of that race. Does that mean he traveled 1.39 meters per second the entire race? Probably not. He probably was going a little bit faster at some points, a little bit slower at others. But the overall average speed for the entire race is 1.39 meters per second. Thank you for following this, and stay tuned for more videos. Goodbye.